Okay, so I tried having a live stream last. I got feedback saying that the connection quality was too bad, and I should a live stream. So I'm pre-recording this questions that I see on the help sheet. One thing I will say is um, that help spreadsheet is split into several tabs. Tabs are at the bottom of the screen, and should put your question in the tab that corresponds with your class. So that when I go to the classes, I have all of the questions sorted out. But um, I found a lot of questions being placed on the wrong tab, just the first tab that came up instead of the tab that corresponded to the class. Okay, so let's take a look. Question number one on was wanted to look at any type of problem that has parentheses, negative powers, or fractions. I think this might be from my basic algebra class, and it's not really detailed enough for me to know exactly what's being asked for. But I think that the is fractions. I think this is from my basic algebra. But if you're in the trigonometry class or the calculus class, and one of the comments that I also said is um, they wanted to have recordings that were separated in trigonometry and calculus. And that's a great thing, except that all of these questions are mixed up on this sheet here because calculus students and the trigonometry students put their questions on the same page as basic algebra, because the basic algebra tab is the one that it defaults. Anyway, I think that fraction that's what we're talking about. I think this is a basic algebra. Next one says, where's the answer key to the practice tests? I don't have any answer keys to these tests. If you'd like me to send you a solution, feel free to ask and I will write up a solution. But I don't have keys. Okay. It says, will there be any way to make up points for missed questions on unit tests? No. No, there will not be retakes or redo problems. Will there be online lectures, or will we mainly get information from the textbook? So, um, online classes are done in lots of different ways, but usually you get your information from the textbook. I have decided to do these live streams, which I'm planning on doing on Mondays and Fridays. And if they go over well, and there's demand, maybe I'll add another one. But Monday this week was Labor Day, and today is Friday, so I'm doing a recording now. I said live streams. The student said that the recording quality was not good enough for that, so we're just gonna do recordings. I'll record them on Mondays and Fridays, and then I'll upload them. So so we'll do two of these, but but this is the first semester that I'm trying out the online lectures because and it's something that I've kind of wanted to do for a while, but I've never actually had the time to. But I'm gonna try and do online lectures for these classes. Normally, yeah, you textbook and then you can ask me questions and I respond to them. We do more graphing problems so we can understand better, please. For graphing, I think that the best way to practice graphing is probably using Desmos. I can pull up Desmos, show you. But what I would do is I would try graphing something by hand, and then I would go to Desmos and type in the thing that I tried to graph, and I'd see if my graph matches their graph. So this is Desmos. What this? Here we go. Okay, this is Desmos. If I want to practice graphing quadratics, let's say, I might go and practice. I will look at my equation. Maybe my equation is y equals x squared um, minus 4x plus 2. So I have this quadratic here. I might use the quadratic formula to find the roots, plug in 0 to find the y-intercept, use the vertex formula to find the vertex, and then graph that. Then, after I graph that, I plug it into Desmos, and I see how close did my graph come to reality. So that's how I would practice graphing. That works for all graphing. So you're graphing trig functions and trigonometry, graphing polynomials or logarithms and calculus, works for all of that. I would recommend practicing with Desmos. Um, okay. So here was the comment, said streaming had intermittent audio loss, and the lecture was broken and incomplete. So we won't be doing live streams. We'll be doing recorded sessions. Can we have direct topics in trig that will enable us to calculus? Okay, so this is either a student in trigonometry who's forward thinking and wants to prep for calculus, or a calculus student who wants a review of trigonometry. If this is the second, a calculus student who wants a review of trigonometry, then on this channel I have a playlist of basically all of the trigonometry you need for calculus. It's not all of the trigonometry you need for trigonometry, but it is a quick review that you can get through in an hour, maybe 2 hours, just teaching you all of the trigonometry you need for a calculus. So if you're a calc student wanting a review, that's there. If you're a trig student who's thinking ahead, that might also be what you're looking for. Can you please tell us at the end of class which assignments to get done? I thought it was one each night, and I'm having to do 5 in one day, or at least tell us a good day to do for more that are. This sounds like my basic algebra class. So I will let that. I'll answer. But so answer to that question is that the assignments have their due dates on the day of the test. Turn in your homework on the day of the test in that class. So pace yourself out and look at how much work you have, look at when the deadline is, and divide it out across the days that you have. For question 1, section 1.6, add and subtract fractions. Okay, that sounds like a basic algebra question, so we'll add fractions class on Monday. No concerns. Great. I would like more problems where we need to find the sides of a right triangle being given only. You can't find the sides of a right triangle given only. So you need, like, if you're told the angles on a right triangle, you don't have any information that will tell you the side length. If you're told some other piece, maybe if you're told one of the sides or you're told the area or something, then you'd have enough information to find the other side length. But if your question, like, if the question is, we have a right triangle and one side and we want to find the other sides, that's a problem that would be common. Let's do a few of those. Let's suppose I have a right triangle, and let's suppose this angle is 37. Okay. Then let's pick one of the sides, maybe this one. Let's say this has a length of 4, and I want to know what the other two sides are. Well, my three main trig functions are sine, cosine, tangent. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the. So looking at this, if I want this side and I know this one, this is the hypotenuse because it's opposite the right angle. This is the opposite because it's opposite the angle we know. And so to find that missing side, we're going to use the trig function that has both opposite and hypotenuse. Set up sine of 37 degrees equals the opposite over the hypotenuse. We don't know. We solve. X equals 4 over sine of 7 degrees. Now we plug that into a calculator and we get a side. For this side, we now know the opposite. We're looking for the adjacent. So set up the tangent because it's opposite and adjacent. Tangent of 37 degrees equals the opposite, which we know, over the adjacent, which we don't. I'm going to use y because I already. Y equals over the tangent of 37 degrees. This gives us the one missing side. This is the other missing side. If we want an approximation, we can use a calculator. I'll do more of these at the end, but I'll split into trig and calculus. Question is, will there be a calculator allowed for tests or only on certain problems? That depends on the class. So, I believe that on the trig test, it says you can use a calculator, and on the calculus test, it says you cannot. That's what it says. But I have that information in the description of the test when you open up. You go to Canvas and test, it'll give a description. Are there answers to homework questions? I don't have a key for that. You send me and ask me on a question that you're unsure of. You can ask me to write one up. Ultimately, like at first as you're learning, maybe you're unsure of what correct and incorrect answers would look like, but and hopefully, like, going through these videos, hopefully I can make some videos that will help get over that hurdle. But eventually you should get to a point where as you're doing the problems, you know when you get stuck and when you're not stuck. So you shouldn't really need answer key, because you'll either be working through it and you'll get to the end and you'll know the answer, or you'll be working through it and you'll know, wait, I don't know how to figure out the next step. I got stuck here. And you won't be in the case where you start working on a problem, you work on it, you get an answer at the end, and then you're unsure if it's right or wrong. Like if that happens, then you don't really understand the process. So you should go back to the text and um read how to do the thing. I think a lot of times with math classes we kind of cheat ourselves on material, because when we get stuck we look for the answer instead of going text and reading up the definitions of terms that we don't know, looking at example problems and seeing what we've done, and reading the theory about the problem rather than copying a. But if you're stuck on a question, send me a question and I will answer. It's likely that if you're stuck on something, other people in the class are too. I can put. Another question about calculate. So the answer to that is I'll have descriptions on the tests when can and cannot calculator. You cannot use a graphing calculator. That's too powerful an item for tests that I'm writing. No graphing calculator, but scientific calculator needed on some tests, and some tests that'll be in. Will a unit circle be included on the exams? Memorize the trigonometric. You should memorize that circle. I have a video for that reveals a lot of the patterns inside of it that help you to memorize the values quickly in my trigonometry playlist. But yeah, if you're in a trig class, you should spend some time memorizing the. Get an answer key. Some of the questions, not all of them. Yeah, okay. So I'll open up quiz 1 when we're done going through these questions. We'll do some trig questions for calculus. So syllabus says no calculators on quiz 1 asks for rounding to decimal places. The quizzes are not exams. Okay, so you could feel free to use calculators on homework and quizzes. That's fine. No, you're not expected to solve irrational square roots by hand, but quizzes are not exams. So feel free to use Desmos on a quiz. So a graphing calculator, use a scientific calculator. Quizzes, you can use anything for them. They're basically homework assignments that get automatically graded. Do it, see if you got it right. Didn't, reread the second book. Do it again. The computer doesn't care if you submit it 10 times. The computer will grade it for you back instantly. Deal with plus or minus square root. Deal with my basic my basic algebra class is not doing. Deal with plus or minus. Not sure what that means. I'm not sure I can help with that. So maybe what's being asked is if we're asking like x squared minus 4 equals 0. If we're solving this equation, like move the 4 to the other side, we get squared equals 4, and then we take the square root and we get x plus or minus the square root of 4, which is plus or minus. You might be asking, well, why is there a plus or minus on our square root question? The answer is I take either of these values and plug them back into the function, I get 2 squared minus 4 equals 0. That gives us 4 minus 4 equals 0, and that balances. But I also get negative 2 squared minus 4, 0, where negative 2 times negative 2 is also positive 4. 4 minus 4 still equals 0. So both of these are solutions to the problem. X can equal 2, or X can equal negative 2. Both of them give a solution to the original problem. Is that what we're asking for? Um, one nice thing is that whatever the degree of our function is, whatever the degree of our function, we have a degree 2 function. That's the number of solutions we're going to have if you. So we have um, a line like x plus 3, 5, a linear function, degree 1 polynomial. We know that x equals 2. There's one solution because it's one polynomial. But if we have a higher degree, like x squared plus 3, 5, then we're going to get two squared, the square root of 2, negative square. And if you go higher than that, then you're going to get more. The degree is going to equal the number of. Okay. Next question. And we have more resources to help us understand these concepts. So I will record on Fridays videos. There's also Khan Academy works works very well, and yeah, you can email me questions, and you can find lots of resources. But textbook, a little challenging to read. Not like a regular book where you can sit down and half an hour, 30 pages for an hour in a chapter book story. It's a lot slower. You have to stop and think about what's said. I would say that as you're reading a textbook, math textbook, you might only read like 4 or 5 pages a day. Homework problems, the example problems as you go. But it's a good skill to, and hopefully these videos. More visuals laying out the concepts, textbook pretty, it's hard to map out what's being said. Yeah, it's a skill. It would be a good idea to or like hopefully these videos or on Academy sending me emails and I'll give you, hopefully those help. Can we get a study guide for the test? So so for the trigonometry class, I have the quizzes are going to be similar questions to the test question. So the study guide for, let's look at trigonometry. So for trigonometry, I'm going to pull up the exam this screen and pull up quizzes on another screen. So quiz 1 have converting radians to degrees, radians. Those are both things on the test. Test has test has a couple questions on radians, has a couple questions on arc length, has question triangle. So those questions are on quiz 1. So if you feel good, if you want a study guide for the first exam, I would say look at quiz 1. Let's look at if I look at who yeah, quiz 2 has a few graphing questions. There aren't any graphing. Not this. They'll be on the. Have arc length, rotational velocity questions. So yeah, if you look at quiz 1 and quiz 2, those are the study guides for example. Okay, let's look at calculus. Study guide for exam 1 in calculus. You click on here's the so if I click on exam 1, there's a study guide description. Okay. That so those are all the questions that I got on well actually those are all the questions I got on the help spreadsheet wrong tab. Look at trigonometry. Trigonometry tab is blank. Calculus tab is also. So from now on, you could put your questions on the correct tab. Then I'll be able to separate them, and I can do one video for trig, one video for calculus, and not have to mix them. So let's do. Last week, I wanted to do some videos for the calculus class. I didn't have time to get back to it. So let's start by looking at stuff for the calculus class. Then we'll do stuff for the trig class afterwards. So I open up one study guide. So the study guide has 20 questions. They're all about I will do I'll do all of the ones that are divisible by 4. If you want me to do other ones, send me a message. I'll them on Monday. But let's look at question 4 on the study guide. It says, what is the limit as x goes to 0 of e to the x? So the rule is for any continuous function, for any element function, the value of the function equals its limit. So you just plug 0 in. Anything to the 0 power is 1. So that's the answer. 8. Limit as x goes to 3 of x 3x squared minus 5x plus 3. And this is continuous because polynomial. Polynomials are elementary functions. All elementary functions are continuous in domain. So we plug 3 into that. We get 3 times squared minus 5 times 3 plus 3 gives us 9 minus plus 3, which is that's right. 12. 12 is the limit as x1 of x1. This is a little bit tricky because it looks like a function that has a discontinuity at 1 because it's a rational function, but the discontinuity is actually at x equals 1. That's the problem spot. So if since we're not actually looking at the problem spot, which is x equals -1, this is still a continuous function at 1, so we just plug in 1. Squared minus 1. 1. This gives us 0 over 1. Okay. Let's look at number 16. Have the limit as x goes to 0 of 1 over cosine minus 1. So with this, if I try plugging in 0, I'm going to get 1 over cosine of 0 minus 1, which 1 over cosine of 0 is 1 minus. This gives me 1 over 0, which is. So since this is undefined, that means the limit does not exist. So this is our first example of a non-continuous function in the problems that I selected to do on camera, and one where the limit didn't. 20, we have the limit as x goes to 0 of x squared minus 1 over minus 1. With this one, when we try and plug in 0, we get 1 squared minus 1 over 0 minus 1. And this gives us, copy that. The limit as x goes to -1 of x squared minus 1 minus 1. This one here, the bad point is x positive 1. This is the problem point. We're also not turning in, or we're not plugging in the problem point. We're plugging in -1. This one actually plug in -1. On the top, we're going to get 1 minus 1. On the bottom, we get -1. -1 minus 1, which is 0. Let's swap this problem here. I'll do an alternate version. Prime. Limit as x goes to 1. x squared minus 1. Now, the problem point is still x minus 1 because I didn't change. But now we're doing a limit as we go to that. So with this, if we tried plugging this in, what we get is 1 squared minus 1 over 1 minus 1 gives us 0 over 0. This is an indeterminate form. Indeterminate forms are 0 over 0, infinity over infinity, and a few others that we won't worry about until chapter 4. Those are the two that we want to look for right now. So when we have an indeterminate form, that means the limit might exist, but it's not currently in a form that we can see what the limit is. And the way that we fix that with this type of indeterminate form, we'll learn other techniques in chapter 4, is we're going to factor the top and bottom and try and cancel out our problem factor. The top factors is x minus 1, x plus 1. Bottom factors is x minus 1. Cancel that. Limit as x goes to 1 of x plus 1. Now we no longer have an indeterminate form. This is a continuous function because it's a line. Lines are continuous everywhere. That means that I can just plug 1 in, plus 1, gives me 2. That's the limit here. This is the type of limit problem that we could practice, the type where you have to get a 0 over 0 when you plug in, and you're going to have to factor and cancel. Factoring is a skill from college algebra, so I'm not going to go over that right now, but factoring, canceling, two skills you should be skilled at from a previous class. And the calculus part of this is figuring out when is the point that you're going toward a bad point, meaning usually a factor of the denominator. And when that happens, you use skills from previous classes to factor and cancel so that now when you go to the limiting point, you no longer have an indeterminate form. Plug it in and you get a value. That's the main crux of the problem. The other problems we did here were all kind of the ones that you don't have to do the canceling part. It doesn't need to have a canceling part, but you should look for being able to cancel solve limits. Okay, those are the ones I want to do from this sheet. Now I'm going to go show you for the calculus class. We have go to the dashboard on this. So scroll down. I have a module called exam practice. This is going to be the chapter 1 and practice that you're going to look at. I'm going to do the problems on this with you. So the first problem, one where we have a graph. I'm going to draw a graph here. So maybe the graph will look. Okay, here's a graph, and then it asks you about a limit. Limit as x goes to, let's say that this is 2 and negative 2. Let's say the limit as x goes to 2 from the right of f of x. Well, this is where x 2. If I come from this side toward point, then it looks like I hit a value of negative 2. This means coming from the right, from bigger numbers than 2. The limit as x goes to 2 from the left. If I come at 2 like this, we'll call that point 1. So my limit from the left side is 1. The limit as x goes to negative 2 from the right So from here, going that way, looks like, call that point the point negative 2, 2. And if I come from the left, maybe that, like, negative 2 is the y coordinate. So we have a few questions that are like that, where we will find limits from the left and the right. We might also have trickier questions like, what is the limit goes to 4 of f of x? Well, now we're looking at x's here. And we have a two-sided limit, so are we going to the same point on both sides? And in this case we are, and it is from both sides. That's what it would look like graphing. So there's the limit, which is decided. We have we're coming at both sides. See what the y coordinate is. Usually we say that the limit is L. Y value is. We also have one-sided limits where we have a point that we're looking at, but we're only interested in what the y coordinate is from one side. If the y coordinate that the function goes toward on both sides is go to this y coordinate sides, say that the limit as x goes to a of f of x from the left, limit goes to a from the right, and whenever the left and right limits are equal, sided limit exists and equal. We have a function where we have break like this. We have a left limit down here, right limit up here. Since they're not equal, we say that the limit as x goes to b of x does not. Even though the limits for each side exist, the limits aren't equal from both sides, the general limit, two-sided limit. You have to be able to classify types of continuities. This one called removable. One called a jump. This one called asymptotic. This one called oscillating. These three are called irremovable discontinuities. And these ones, the asymptotic ones, are also sometimes called There's removable. That's when you have one hole in the graph. There are asymptotic, jump, and oscillating that are all types of irremovable discomfort. And asymptotic are also called infinite. Um, so on the study guide, I have a question about go back to the okay. So I do have a classifier. So we have intermediate value theorem and okay. So let's talk about the intermediate value theorem says that well, the thing is that um, continuous functions don't follow. It's stated like this: if f of x continuous on a to b and y f of then there exists between a and b such that f of that is the statement. What it means is that if I have a continuous function and this is the point a f of a and this is the point b f of b and this is some y value, the way that I get from a f of a to b f of b is I have to cross y somewhere. So there is some x value c so that f of c equals y. So that f had to hit y, hit the line y at some point. That's the picture. So questions of this type might be something like f of x equals x squared minus 4. Does the intermediate value show that f of x equals 0 mean x equals -2, x equals, okay? So this might be a question that you get. The answer is we go, well, f is continuous, polynomial, so it's continuous. F of -2 equals, well, I just happened to, let's say -3. F of -3 equals -3 squared minus 4, so that's going to be 9 minus 4 equals 5. F of other value, 4, is 4 squared minus 4, which equals 16 minus 4, which equals 12. And my answer is intermediate value theorem does not include that. So since these are both positive, 0 is not between them. So the intermediate value theorem doesn't prove that there's a solution between -3 and 4. However, same function, f of x equals x squared minus 4. Let's see, does the intermediate value theorem prove that there is a root of this function between 0 and 4? Same question, but we're replacing this and that. Or I guess this is this, but we're replacing the interval. Now we go f of 0 equals 0 squared minus 4 equals -4. F of 4 still equals 4 squared minus 4 equals 12. 0 is between these. So the intermediate value theorem says that f of c0, or some c between 0 and 4. Okay? So the intermediate value theorem is a nice tool that says, oh, if I'm positive here and negative there, I had to be 0 somewhere in between because my function is continuous. Or similar things like that. It doesn't say where the function equals 0 or whatever value you're checking against. It just says that it had to do it somewhere because the function's continuous. But only if you can find, for the value you're trying to prove, you have to find an x that makes f below that and an f that makes above that. Okay, let's look at the. So the squeeze theorem says if the limit as x goes to a of f of x was the limit as x goes to a of g of x, and f of x is less than h of x less than x, then the limit as x goes to a of h of x equals the limit as x goes to a of f of x, which is the same as g of x because we said that these limits are. The picture for this would be canonically something. Here's my function f. Here's my function p. They touch right there. And here's my function. Very wiggly function. Very hard to compute. Lots of wiggles. Very bad. But we know for some reason that it is below f and above g. And since f and g touch here, that means that h of x has a limit between them. That the limit as x goes to that point is the same as the limit as f goes to that point and the same as g going to that point. There's the picture. So that's the picture example. The usual example is the usual algebraic example is sine of x over x as x goes to. Now this graph here looks a lot like squared root. So this is the graph of x squared. Here's the graph of negative x squared. They touch at that middle point at x equals 0. And sine of x over x squared looks something like this. It just bounces like crazy. Well, this one bounces better. This one bounces like crazy between these two. And it's very difficult to look at a graph and see what's going on. So if I squeeze it above and below, I know that the limit as x goes to 0 of x squared equals 0 because this is a continuous function. And so the value is the limit. Same thing here. The value of negative x squared is the value of the limit. Those two are equal, which satisfies the condition of the two limits having to be equal, this limit condition. And this function is between these two. Look at this here. This function is going to bounce up and down between these two functions because sine is always less than or equal to 1. So this is less than or equal to 1 over little bit. Canonical example is actually squared. Okay. There we go. So the canonical example. So sine of 1 over x squared times that is going to be less than x squared because this is always less than or equal to 1. But this is also going to be greater than or equal to negative x squared because this is always, sine is always greater than or equal to negative 1. So we have this bounding above and below by these two parabolas. And we have this function that wiggles a ton, but gets squished down to having a limit that's equal to the other two, as the other two functions. So let's pull up Desmos. Nice graph. Desmos. Here's our x squared graph. Here's our negative x squared graph. Here is our x squared sine of zoom in, see all of these wiggles. But again, it stays below the red curve and above the blue curve. That will see. opposite. That doesn't sound. Those wiggle. There are infinitely more we zoom, or we'll see. Okay. And that covers everything that'll show up on the exam. Should feel good with calculus. Let's go to trigonometry. Okay. So for the trigonometry one, and quiz 1 and quiz 2 are going to be what you want to look at. But let's pick this question. Particle traveling circular path with radius 3 at feet of 7 halves pi radius. How fast is the particle traveling in inches per? So circle is 3, and we're going 7 pi over 2 radians. Well, it's 2 pi radians to go around. So um, so going once around 2 pi radians, the radius, figure out the distance around. Actually, probably. So this is how many radians we're going around every minute. But a radian is just the distance of the radius around the circle. So if the radius is 3, then 1 radian is 3 units around the circle. So if we're going 7 pi over 2 radians per minute, that's 7 pi over 2 times the radius of the circle every minute. So this here becomes 21 pi over 2. I can plug that into a calculator. That I already. One. That's says you may use a scientific calculator. So we have 21 times pi over 2. Pull up our calculator. 21 pi. Button is here. 2. Get 32,986. And the quiz says round to 2 decimal places. So we round up because the third decimal place is 6, so this will be 32.99. 32.99 inches per minute. You'll just put the number in. Worry about typing the, or at least not on this question. Length. Well, the arc length is just the same as linear speed, except that you're not dividing by. So, like, the difference in wording is instead of saying at a rate 7 pi radians, says a particle traveled 7 pi radians. Where did they go? That many inches. The only difference is you're not going to dividing by minute. But let's do a problem like that. So, arc length of a circle of radius 4. Central angle of pi over b radians. A is 10 pi over radians. Applies to 5 pi over 3. Round to 2 times. Well, 5 pi over 3 is about that far around the circle. Because there are 2 pi go all the way around, that's the same 6 pi over. This is just pi over 3 away from a circle. And the radius is 14, so 1 radian would be 14 all the way. 1 radian around. 1 radian is 14, then not 6 pi. 5 pi over 3 times 14 is going to be the number of. It doesn't give a unit. It gives the angle. This is the angle in radians. This is the radius. We multiply them together. 14 times 5 is 70 pi over 3. Plug that into our calculator. Pi divided by 3 gives us 73 units. And I think we already talked about reference angles last week. That converting radians, degrees and degrees into radians. 2 and right triangle tree. We already did one where I gave you one side, asked you to find the other two. So let's do a similar triangle one where I have 3 that's is 5 feet tall, so it's a sapling, but casts a shadow 4 feet long. Should have drawn the trunk after reading that. Another tree, big and 77 foot. You want to know how tall is the second tree? Trees usually go vertically. Okay, so with this, we're trying to figure out how tall the tree is. We can set this up a bunch of ways, but I recommend making sure that the variable is in the numerator, just because it saves you. I can either do x over the other side of the same triangle, or x over the same side of the other triangle. So either way, I can do 77, in which case, since I'm doing this over this, I have to mirror that by this over this. If I do it the other way, this, then I have to mirror it by doing this over. Either way, x is vertical side of the big triangle, which means that the horizontal side of the small triangle needs to be diagonal across the equal sign. Set up the problem. Other two, these ones can switch, and it'll end up giving us. Set it up how you'd like. And then the next thing to do is get the x by itself by multiplying by the denominator. We'll either get 5 times 77 over 4, or we'll get 77 times 5 over 4, whichever way you wanted to do it. 5 times 77 is going to be 85. 4. And it wants it nearest hundredths. We're going to need to put it in decimal. So 4 goes into 36, goes into 38 9 times with the 2. Down to 5, 4 goes into 25 6 times with the 1. And then 4 goes into 1 5 times. So 96.5 height of the tree. 96. There we go. That should be like this video plus the last video. Cover everything that's going to be on the test for the trigonometry. I think I'm going to call this recording. Oh, there we go. There are a couple of questions. This, but I think I can respond privately. Okay, so we'll call that good. We'll stop recording and upload the video. Good luck on your test.